based on the science in our 2016 report that showed that because outbreaking cots tend to cluster around the edge of a reef, and because it's very hard to predict in advance where those clusters will be located, the best thing you can do is man-to-toe the reef to identify where those clusters are and target your control at those locations. And that works because even though man-to-toe takes effort, and even though man-to-toe doesn't have perfect detectability, as we've heard today, it can detect those large, dense clusters of cots well enough to target control actions. In that 2016 report, we showed that taking the time to man-to-toe and then targeting your control actions using that information could increase the efficiency of the previous control program by 33 to 55%. And so in the current control program, we use the same approach. The big innovation in this space that's going to revolutionise this space really is probably new monitoring techniques like the glider technology that Brett talked about earlier today. That's going to allow us to survey much larger areas and therefore target our control and optimise the efficiency of the control program significantly. Once you've man-to-toed, you need to decide whether you need to cull or not. So the decision support system includes a relatively simple rule to answer this question based on the data you just collected in the man-to-toe. If no cots or cut scar is seen in any man-to-toe around the reef, we don't need to dive at the reef, otherwise we do. There's a lot of nuance to this simple rule, but the most important thing to know is that since the new control program rolled out in November 2018, we've been tracking the performance of this rule. And Dave talked about it yesterday. It has a false negative rate of about 3% and a false positive rate of something above 50% at the moment. And that's a good balance because we really don't want false negatives. A false negative would mean that we don't dive at a reef where cots are consuming coral faster than it grows. But we're not too worried about false positives because it's relatively cheap and efficient to identify the fact that we've got a false positive and quickly move on to the next reef on the GBR. But this is one place where we can make improvements in the very near future to the efficiency of the control program. So by refining those rules slightly so that we reduce the false positive rate, will increase the efficiency of control. One of the ways we may do that, again, may be the gliders. Once we decide to cull at a reef, we need to know which order we should cull the sites in. The rule here is not super complicated. We start with the sites that have the highest densities of cots. And we do that because, as I noted before, the control program has the biggest impact when it hits those high density clusters, and the faster we hit them, the more coral we save. However, interpreting man-to-toe data and combining it with cull data is something that a computer can do more easily than a human. And so the COTS Control Centre uses a hybrid modelling approach, synthesising cull data where it can because it's finer scale and more accurate, and combining it with man-to-toe data where it needs to because that provides full coverage, and then it provides the list of the sites that need to be dived in the order that will maximise the ecological outcome for that reef. This is an area where we're likely to make important refinements. In future, we're going to be leveraging an artificial intelligence approach to better predict where future COTS densities at reefs and sites based on covariates at a per reef and per site basis. We've got a postdoc working on this now, so the hope is that that will be ready in the not too distant future. And again, that will increase the efficiency of the control program by making sure that we're culling the sites in the order that most quickly saves coral and reduces COTS. Once we start culling at a site, we also need to know when we can stop culling. This is a conceptually simple problem, but it requires a detailed ecological and biological understanding in order to provide that estimate. We want to keep going back to cull cots at a site until the density is reduced sufficiently that coral can grow faster than the cots that remain there can eat it. So this is based on a threshold that was calculated by Russ and Eva and co-authors back in 2015. And the decision support system estimates whether cots at each site following each manto and each culling session are below the thresholds in that report, and when all sites at a reef are below that threshold, it recommends moving control to the next reef. This is an area where in my opinion, we're likely to be able to make significant improvements to the efficiency of the control program through refining those thresholds, which I believe Eva and Jacob will be talking about later this session. We also need to know how frequently to cull sites. Ecologically, the optimal answer to this question depends on whether the cots we find when we go back to a site were there last time and we just happened to miss them, or whether they immigrated into that site after we culled. Back in 2017, we used a simple analysis of historical control program data to show that sites that were dived more frequently tended to have a higher proportion of smaller cots, and that suggests that the main driver of population recovery after culling was detectability rather than immigration. This conclusion has since been supported by some of the field work that Morgan talked about earlier today that showed that cots, when there's abundant coral, cots don't necessarily, even though they can move, they don't go out and move around the reef that much. We modelled the optimum management strategy under these scenarios and found that frequent revisitation saved the most coral by a significant margin. So the decision support system recommends diving at each site every voyage, or roughly every 14 days. And that's compared in the pre-IPM control program, that was once every 3 to 6 months, depending on the resources that were available at the time. So the final question is the control program working? Is it working to control cots at sites? Is it protecting reefs? And is the way we're distributing vessel time across regions working? We can now say with some confidence that the answer to all three of these questions is yes. Yesterday, Dave talked through our early results showing that even under the old control program, individual sites that were visited frequently, we did manage to save coral at. The big innovation with the new IPM control program is that now we're protecting entire reefs. And that's the underlying goal of the program. So that's a pretty major outcome of this work. And I think Dave mentioned yesterday that in the first 20 months of the control program, I think 92 reefs were reduced below by the on-water crews below the ecological threshold, and 81 reefs, I think, were found to be below that threshold when they visited them. So that's a major outcome in the first 20 months of the program. And finally, through a large and coordinated research effort, developing GBR scale COTS models, that's CocoNet at CSIRO and ReefMod GBR at UQ, we can now say that the regional strategy that we're using in the current COTS control program, by which I mean both the selection of priority reefs and the use of the decision tree process to direct resources around the GBR, is equal or outperforms any of the other regional strategies that we tested in the NESP report that just came out about regional modelling strategies. So this is, and I believe Scott will be talking about that later in this session. So this area is exciting because now we know not only that we're achieving the goals that were set up for the NESP COTS control program back in 2015, but we're right on the cusp of being able to understand how to suppress or control COTS at the scale of the entire GBR, or maybe even think about seriously preventing future outbreaks. So that's it. Wrong button. That's it. That's the decision support system that we've all developed to underpin Australia's COTS IPM control program, and it's how it delivers decision recommendations to the people that need them. It's the science it's based on, and it's the innovations that are just around the corner under CSIP. Hopefully, as you listen to the rest of the presentations in this session, you'll be able to see how they have contributed and how they will be contributing to on-water decision making in the future. And like I said, it feels like we're right on the cusp of something really major here, and it's a really exciting time to be working in this space. Thank you.